Everyone. Today we're going to talk about an introduction to pH. Now you've probably all heard the term pH before, but I'm not sure if everybody understands exactly what it stands for. So let's start with the basic definition. And a basic definition of pH is that pH equals minus the logarithm in base 10 of the hydrogen ion concentration. So to know what the pH of something is, you need to know how many hydrogen ions there are in something. And in general, the more hydrogen ions you have, the more acidic a solution would be. This is kind of the Arrhenius definition of an acid. The more hydrogen ions you have, the more acidic the solution is. Now, what makes this a little odd sometimes for people is this pesky negative sign in the formula. Because of that negative sign, the more hydrogen ions you have, the lower the pH. Because of the way the formula is constructed, the more hydrogen ions you have, the more negative this is going to get. So the lower the number it's going to be. So for that reason, acid solutions have a pH of less than 7. And basic solutions have a pH of greater than 7. Okay? Now, water, of course, is what we call a neutral solution. Okay? And water is defined as having a pH of 7. That's a neutral solution. So what that means is that the hydrogen ion concentration in water is 1 times 10 to the minus 7th. Because if you put 10 to the minus 7th in your calculator, take the logarithm, you get minus 7, and then you use the negative sign, which switches it to positive, and it becomes positive 7. In water, which is a neutral solution, the hydroxide ion concentration, tells you how much base there is also 1 times 10 to the minus 7th. So the hydrogen ions are exactly neutralized or exactly equal to the hydroxide ions. So that's why we say water is neutral. Now because of this, you can kind of do sort of a cool math trick, which is that the pH plus the pOH in any water-based solution, and in our class we're just going to deal with water-based solutions. Since water is neutral as a pH of 7, the pH plus the pOH of any solution will up to 14. And this kind of allows us to do a couple of different things. If we know what the hydrogen ion concentration of something is, we can use that to calculate the pH. If we know what the pH is, we can use that to figure out the pOH. And then by taking something called the inverse log of the pOH, you can figure out the hydroxide ion concentration. Let me show you what I'm talking about here. Okay, so let's just do a really simple problem. Now, if you have your calculator with you, this would be a good time to fire up the calculator, all right? So let's say we have a solution where the hydrogen concentration is 1 times 10 to the minus 5th molar, okay? So if the hydrogen ion concentration is 1 times 10 to the minus 5th, the pH of that solution is going to be minus the logarithm, 10 to the minus 5th. Put this in your calculator, and what keystrokes you use are going to depend on what kind of calculator you have. I'm going to pull out my TI 30XA, since that's the calculator we're using in chemistry class. Okay, so let me turn this on. I put in 1, and then I hit the EE, and then negative 5. That's how I get 1 times 10 to the negative 5th. I take the log of that, and that gives me negative 5. And then because this formula has a negative sign, I change that to a negative number, and I get the pH is 5. Okay? Now in the previous slide, we said that the pH plus the pOH always has to equal 14. So that means the pOH is going to be 14 minus the pH. So in this problem, the pOH is going to be 14 minus 5, or 9. And that tells you the pOH, or how basic something is. All right? Finally, we want to find the hydroxide ion concentration. How much base is there in that solution? Well, that is just going to be the number 10 raised to the minus pOH power. Okay? So it's going to be 10 to the minus 9, since we already calculated that the pOH is 9. So another way to write that is just 1 times 10 to the negative 9, which is the same as 10 to the negative 9, and that tells you the hydroxide ion concentration. All right, so those are some really simple ones. In our next video, we're going to do one where the pH is not 1 times something, but a slightly more complicated number. So make sure you have your calculator with the logarithmic function ready before you watch the next video. Bye now.